The Mike Holt electrical training videos are highly regarded in the electrical industry and cover several key areas of electrical work. Firstly, the equipment for general use, articles 400 through 460, focuses on important electrical equipment, including motors, generators, transformers, and switchboards. This section provides a thorough understanding of their installation, operation, and maintenance. It is useful for both entry-level and experienced electricians working with general-purpose electrical equipment. Secondly, special occupancies, articles 500 through 590, focuses on electrical installations in specific types of occupancies such as hospitals, assembly halls, and hazardous locations. This section explains the unique electrical requirements and safety considerations for these occupancies. It is essential for electricians working in specialized environments. Thirdly, special equipment, articles 600 through 702, covers specialized electrical equipment such as elevators, fire alarm systems, and electric signs. This section provides insights into their design, installation, and testing procedures and is important for electricians responsible for installing and maintaining these types of equipment. Fourthly, limited energy and communications systems, articles 720 through 830, explores the latest advancements in low voltage and communications systems, including fiber optics and structured cabling. This section explains the principles of operation, installation, and troubleshooting for these technologies and is valuable for electricians working with data, voice, and video systems. These Mike Holt videos are well known for their clear and engaging presentations. They use a user-friendly style that makes complex topics easy to understand. The videos also provide in-depth coverage, offering comprehensive explanations of code requirements and industry best practices. The training is also aligned with the latest editions of the National Electrical Code. These videos are beneficial for both apprentice electricians and experienced professionals seeking to enhance their knowledge. The content covers a range of essential electrical topics, providing a solid foundation in electrical theory and practice. The videos on equipment for general use are particularly valuable for understanding the intricacies of motors, generators, transformers, and switchboards. Knowing how to properly install, operate, and maintain these devices is crucial for any electrician working in commercial or industrial settings. The special occupancies videos provide critical information for electricians working in environments with unique electrical requirements. For example, hospitals have stringent regulations to ensure patient safety, while hazardous locations require specialized equipment and wiring methods to prevent explosions or fires. Understanding these requirements is essential for ensuring the safety of occupants and the proper functioning of electrical systems. The special equipment videos delve into the specific design, installation, and testing procedures for equipment like elevators, fire alarm systems, and electric signs. These systems often have complex control circuits and require specialized knowledge to maintain and troubleshoot. The limited energy and communications systems videos cover the rapidly evolving field of low voltage and communications systems. As technology advances, electricians need to stay up to date on the latest trends and techniques in fiber optics, structured cabling, and data, voice, and video systems. Understanding the principles of operation, installation, and troubleshooting for these technologies is essential for electricians working in modern buildings and infrastructure. The videos are designed to be code-focused, ensuring that electricians are aware of the latest requirements and regulations. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. By staying up to date on the latest edition of the code, electricians can ensure that their work meets the highest standards of safety and quality. The videos are also designed to be widely applicable, meaning that they are beneficial for electricians of all levels of experience. Apprentice electricians can use the videos to build a strong foundation in electrical theory and practice, while experienced professionals can use them to enhance their knowledge and stay up to date on the latest trends and techniques. The videos can help electricians develop a strong understanding of electrical theory and practice. By mastering these concepts, electricians can become more confident and competent in their work and provide better service to their clients. The training materials are designed to be engaging and user-friendly, making it easier for electricians to learn and retain the information. The clear and concise explanations, combined with real-world examples and demonstrations, can help electricians understand even the most complex topics. These videos provide valuable training that can help electricians develop a strong foundation in electrical theory and practice. They offer comprehensive explanations of code requirements and industry best practices, making them an essential resource for electricians of all levels. They cover a wide range of essential electrical topics, from general-purpose equipment to specialized systems and occupancies. The videos are designed to be code-focused, ensuring that electricians are aware of the latest requirements and regulations. The videos are also designed to be widely applicable, meaning that they are beneficial for electricians of all levels of experience. By mastering these concepts, electricians can become more confident and competent in their work and provide better service to their client. The training materials are designed to be engaging and user-friendly, making it easier for electricians to learn and retain the information. They are valuable for understanding the intricacies of motors, generators, transformers, and switchboards. Knowing how to properly install, operate, and maintain these devices is crucial for any electrician working in commercial or industrial settings. The videos provide critical information for electricians working in environments with unique electrical requirements. For example, hospitals have stringent regulations to ensure patient safety, while hazardous locations require specialized equipment and wiring methods to prevent explosions or fires. Understanding these requirements is essential for ensuring the safety of occupants and the proper functioning of electrical systems. The videos delve into the specific design, installation, and testing procedures for equipment like elevators, fire alarm systems, and electric signs. These systems often have complex control circuits and require specialized knowledge to maintain and troubleshoot. The videos cover the rapidly evolving field of low voltage and communication systems. As technology advances, electricians need to stay up to date on the latest trends and techniques in fiber optics, structured cabling, and data, voice, and video systems. Understanding the principles of operation, installation, and troubleshooting for these technologies is essential for electricians working in modern buildings and infrastructure. The circuit breaker's capacity must be sufficient to handle this load, with consideration for any future expansion or additional equipment. Fifthly, appropriate wire sizing for the circuits is essential to ensure safe and efficient operation. The wire size must be selected based on the ampacity requirements of the loads they serve, taking into account factors such as conductor insulation type, ambient temperature, and the length of the run to minimize voltage drop. Sixthly, ensuring that all electrical equipment in the separate building is properly grounded is paramount. This includes light fixtures, heaters, and any other electrical devices. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Finally, the distance between the sub-panel and the separate building should be taken into account when determining conductor lengths. If the distance exceeds allowable limits, intermediate pull boxes may be necessary to facilitate conductor installation and prevent excessive voltage drop. These pull boxes provide access points for pulling conductors through long conduit runs, reducing strain on the conductors and making the installation process easier. In summary, meticulous attention to grounding, bonding, GFCI protection, circuit breaker capacity, wire sizing, equipment grounding, and conductor lengths is essential to ensure a safe and compliant electrical installation for the separate working area building. Adhering to the requirements of the National Electrical Code and employing qualified personnel are crucial for achieving a reliable and safe electrical system. The National Electrical Code Section 250.32 covers grounding requirements for separate buildings or structures. It states that if a building or structure is supplied by a feeder or branch circuit, a grounding electrode system must be installed at the building or structure. This grounding electrode system must be connected to a grounding electrode conductor, which is sized according to National Electrical Code Table 250.66. The grounding electrode system must also be bonded to any metal water piping systems, metal building frames, and other metal objects that are likely to become energized. The purpose of this grounding electrode system is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. This protects people and equipment from electrical shock and damage. The grounding electrode system also helps to stabilize the voltage in the electrical system and reduce electrical noise. In addition to the grounding electrode system, the National Electrical Code also requires that all non-current carrying metal parts of electrical equipment be grounded. This includes enclosures, raceways, and motor frames. Equipment grounding is typically accomplished using equipment grounding conductors, which are sized according to National Electrical Code Table 250.122. Ground fault circuit interrupters are devices that are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. GFCIs are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. When installing a grounding system, it is important to follow all applicable codes and standards, such as the National Electrical Code. It is also important to use qualified personnel to perform the installation. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems to ensure safety and prevent electrical shock hazards. Firstly, Section 250.4 covers general requirements for grounding and bonding, emphasizing the importance of creating a low impedance path for fault current to return to the source. This section also outlines the requirements for grounding electrode systems and equipment grounding conductors. Secondly, Section 250.24 addresses grounding of service-supplied alternating current systems, specifying the requirements for grounding the neutral conductor and connecting it to a grounding electrode system. This section also covers the requirements for sizing the grounding electrode conductor and bonding jumpers. Thirdly, Section 250.32 focuses on grounding requirements for separate buildings or structures supplied by a feeder or branch circuit. This section mandates the installation of a grounding electrode system at each building or structure and provides guidelines for connecting the grounding electrode system to the equipment grounding system and the neutral conductor. Fourthly, Section 250.50 outlines the requirements for grounding electrode systems, including the types of grounding electrodes that are permitted, such as ground rods, ground plates, and metal water pipes. This section also specifies the requirements for installing and bonding grounding electrodes. Sixthly, Section 250.104 covers bonding of metal piping systems and other metal objects that are likely to become energized. This section requires that metal water piping systems, metal gas piping systems, and other metal objects be bonded to the grounding electrode system to create a common ground potential. Seventhly, Section 250.122 provides tables for sizing equipment grounding conductors based on the rating of the overcurrent protection device protecting the circuit. These tables ensure that the equipment grounding conductor is adequately sized to carry fault current back to the source and protect equipment and personnel from electrical shock. Eighthly, Section 300.5 addresses underground installations, including the requirements for direct burial cables and conduits. This section specifies the minimum burial depths for different types of wiring methods and provides guidelines for protecting underground cables from physical damage and corrosion. Finally, Article 547 covers agricultural buildings, which may have specific grounding and bonding requirements due to the presence of livestock and corrosive environment. This article provides additional requirements for grounding electrode systems, equipment grounding conductors, and bonding in agricultural buildings. Complying with these National Electrical Code sections is essential for ensuring a safe and reliable electrical installation that protects people and property from electrical hazards. A 50 amps, 240 volts, single-phase circuit supplying a separate building with both lighting and heating circuits requires careful consideration of several factors to ensure safety and compliance with electrical codes. Firstly, the ampacity of the conductors supplying the separate building must be adequate to handle the total load of the lighting and heating circuits. The National Electrical Code provides guidelines for calculating the ampacity of conductors based on the size and type of the load they serve. The ampacity of the conductors must be at least equal to the non-continuous load plus 125% of the continuous load. Secondly, the overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the conductors from overloads and short circuits. The overcurrent protection device must have an ampacity rating that is no greater than the ampacity of the conductors it protects. Thirdly, the voltage drop in the conductors supplying the separate building must be within acceptable limits to ensure proper operation of the lighting and heating equipment. Excessive voltage drop can cause dimming of lights, reduced heating output, and premature equipment failure. The National Electrical Code recommends that the voltage drop in the feeder conductors should not exceed 3%, and the voltage drop in the branch circuit conductors should not exceed 5%. Fourthly, proper grounding and bonding of the electrical system in the separate building is essential to prevent electrical shock hazards and ensure the safe operation of equipment. The National Electrical Code requires that all non-current carrying metal parts of electrical equipment be grounded, and that the grounding system be properly bonded to the building's metal frame and any metal water piping systems. Fifthly, ground fault circuit interrupters should be installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect ground faults and interrupt the circuit, preventing electrical shock. Sixthly, a wiring method used to supply the separate building must be suitable for the environment and the type of installation. Direct burial cable must be rated for direct burial use and installed at the proper depth to protect it from physical damage. Finally, a qualified electrician should perform the electrical installation in the separate building to ensure that it is done safely and in compliance with all applicable codes and standards. An electrician has the knowledge and experience to properly size conductors, install overcurrent protection devices, ground and bond the electrical system, and select appropriate wiring methods and equipment. When calculating the load for a separate building's lighting and heating circuits, several factors must be considered to ensure the electrical system is adequately sized and safe. Firstly, determine the total wattage of all lighting fixtures to be installed in the separate building. This includes both general lighting and any task lighting. The wattage of each fixture can be found on the fixture's label or in the manufacturer's specifications. Secondly, determine the total wattage of all heating equipment to be installed in a separate building. This includes space heaters, baseboard heaters, and any other heating appliances. The wattage of each heating appliance can be found on the appliance's label or in the manufacturer's specifications. Thirdly, calculate the total volt amperes for lighting by multiplying the total wattage of the lighting fixtures by a demand factor. The demand factor is a percentage that takes into account the fact that not all of the lighting fixtures will be on at the same time. The National Electrical Code provides demand factors for lighting in different types of occupancies. Fourthly, calculate the total volt amperes for heating by multiplying the total wattage of the heating equipment by a demand factor. The demand factor for heating equipment is typically 100%, as all of the heating equipment is likely to be on at the same time. Fifthly, add the total volt amperes for lighting and the total volt amperes for heating to determine the total volt amperes for the separate building. Sixthly, divide the total volt amperes by the voltage of the circuit to determine the total current in amps. For a 240 volt circuit, divide the total volt amperes by 240 volts. Seventhly, select conductors with an ampacity rating that is at least equal to the total current in amps. The National Electrical Code provides tables for determining the ampacity of conductors based on their size, insulation type, and installation method. Eighthly, select an overcurrent protection device, such as a circuit breaker or fuse, with an ampacity rating that is no greater than the ampacity of the conductors it protects. The overcurrent protection device must be sized to protect the conductors from overload and short circuits. Ninthly, consider any future expansion or additional loads that may be added to the separate building. It is a good idea to oversize the conductors and overcurrent protection device to allow for future growth. Finally, consult with a qualified electrician to ensure that the load calculation is accurate and that the electrical system is properly sized and installed in accordance with all applicable codes and standards.